So we were talking about ohmic and non-ohmic conductors, and there is the graph of the non-ohmic conductor. It will not be a straight line graph like the ohmic conductors. And then again, the video stopped when I was talking about the calculation of gradient from the current against voltage graph. So if you are given a graph of a current against voltage and the question requires you to calculate the gradient, it becomes very simple. The gradient for the current voltage graph refers to a certain quantity, and from Ohm's law, V is directly proportional to I, meaning that V is equivalent to IR and I is V over R. So from the graph that we are talking about, the graph of current against voltage, if the question asks you to calculate the gradient, then you have to use the equation V is equals to IR. While using this equation, you make the quantity on the vertical axis, that is the quantity on the y-axis, to be the subject of the formula. And from the graph, current against voltage, the quantity that is on the vertical axis is the current, which is represented by letter I. So you make this equation to have I as the subject of the formula. And when I is the subject of the formula will read as I is equivalent to V over R. So again, you are required to write this equation in the form y is equals to mx plus c. So after you've made I to be the subject of the formula, it should be followed by 1 over R and then multiplied by V, where V refers to what? The quantity on the horizontal axis. So looking at that, the gradient of that graph is 1 over R. So 1 over R is the gradient. Therefore, R will be 1 over the gradient. So if the question asks you to calculate the resistance, you get the resistance by having 1 over the gradient. And remember, anytime you are calculating the gradient of any given graph, the units must always be given. So if you're having a straight line graph with the graph being of current against voltage, what will be the units? If the graph is of a current against voltage, then the units will be what? The quantity that you get when you divide current by the voltage. And the quantity that you get when you divide current and the voltage is 1 over the resistance. So the units for this particular graph will be per ohm, and that quantity whose unit is per ohm is what we refer to as conductance. Conductance is just by the reciprocal of resistance, or rather you can give that as Siemens, S-I-E-M-E-N-S, capital S. So anytime you're given a graph in physics, kindly remember to know what the quantity, the gradient represents. But what if now your graph is not a straight line graph? What if the graph is not a straight line graph? For instance, now you draw the graph, you go to the lab, you carry out an experiment, maybe using a non-ohmic conductor, and the graph comes out, the current against voltage graph comes out to be what? A curve. When it is a curve, we no longer talk about the gradient of that graph, but we will talk about the gradient at a particular instant. For instance, if an exam is having a curve, the graph of the exam is a curve like the one I'm having, you can only be asked to find the gradient at point 1 or the gradient at point 2. So if the question now asks you to calculate the gradient at point 1, what you are supposed to do is to simply draw a tangent at that point. I hope you understand what a tangent is in mathematics. Utachora hapo tangent and you draw another tangent there. And then from the tangent that you'll have drawn, of course my lines are not straight, but from math we know that the Tangent is supposed to be a straight line graph that cuts that curve at only one point. So you'll only be required to draw a tangent, and on that tangent you choose some 2 points. Maybe I choose that point and that other point, and I calculate its gradient. If you calculate the gradient at that point, then you will be coming up with the gradient at that particular point, which is known as the instantaneous change, or rather the instantaneous gradient, the gradient at a certain instant. Just in case you have a question maybe on Ohm's law, feel free to SMS, WhatsApp, or call my number at any particular moment.